everyone, welcome to this video where we will be talking about EVPN multi-homing. In the last video, we have done some ping test and I had explained you how it works in multi-homing. Basically, there were some catchy scenarios that we have talked in the part 1 of this EVPN multi-homing video. If you have missed that, I will put that link into the description for that video as well. But in this video, we will be talking about bump traffic handling with EVPN multi-homing. This EVPN multi-homing is an amazing concept and there is a lot that goes behind the scene. In this video, we will see multi-homing and the concept of DF, which is designated forwarder. When this guy sends some broadcast packet towards C2, let's say, where exactly the DF role come into picture? Will the DF have any role to play here on this side, or DF will have any role to play here on this side? We are sending the traffic in this direction. So that is what we will see in this video. So let's just clear this ink and see when C1 sent the broadcast, is there any significance of designated forwarder on R1 or R2 side, or the DF come into picture for R3 and R4 only? And then why this video? Because I see this is a common confusion. So this video, if you watch till end, I will make sure that you understand this concept better. So let's just get straight into the topic of today. I will clear this ink in this video as well. Before we start, there is a disclaimer that some of the terms that you may hear may not make sense if you do not understand this concept completely. So after this video, and of course, I will try my level best to simplify so that you are not just relying on those terms to understand this scenario that I will be explaining with respect to bump traffic. But if this sparks some interest, there is a complete Udemy course. I will put that link in the description box of this video. And basically in that, I have talked at length about EVPN multi-homing. There is just one dedicated session on that one. So coming back here, here is the topology that we will be talking about, and our host C1 basically sent the bump traffic here. It can be broadcast, unknown, unicast or multicast. I will be talking about the broadcast part. With respect to multi-homing, the benefits that EVPN provide is like active link, active load balancing, and this was something which was not easy with the predecessors of EVPN like VPLS. So if you wanted to achieve the same thing with VPLS, then this was basically not possible. There were some proprietary solutions that came with respect to multi-homing like multi-chassis lag, VPC, and as I had explained in the previous video as well, those were vendor proprietary. EVPN was something which has taken the multi-homing to the next level, not only in the solution standardization aspect, but also there can be multiple PEs that can be connected. Now coming back to our topic, what exactly happened when this guy C1 sent some broadcast? Because this is multi-homing, because this is active multi-homing, this is a port channel. That means this guy C1 can send the traffic on any of these links. And this is where one of my friend, when we were having this conversation, there was some confusion. There is the confusion with respect to designated forwarder. What is this designated forwarder? Designated forwarder in EVPN multihoming is that PE device which actually forward the traffic. Now what does that mean? Each of these devices should forward the traffic. That's what the active means, isn't it? But here is the catch. If you come to me and say that C1 is sending some unicast packet to C2, then it will basically load balanced here or here. It can use any of the link, and R1 and R2 they can forward it, R3 and R4 they can send it towards here. It will be basically some flow based load balancing that happens. If there are two applications, one can go via this path, another one can go via this path. Nothing changes there. But why is the case of broadcast is different? In case of broadcast, first of all, from CE1 side, this is a port channel, a lag interface. That means when the broadcast is generated, it will be sent on either this link or this link based on the hash. In port channel, when we need to send some traffic, it basically calculates the hashing and then pick one underlying physical interface of that port channel. With respect to broadcast, nothing changes here. The same way the traffic will come for broadcast. That means it can either pick this one or this one. Let's say it picked this link 1 and the traffic come to R1. What R1 will do? Because this is broadcast, and in EVPN fabric we have talked about this in that course, that either there can be ingress replication or there can be multicast. So if you don't understand this, there is a link in the description about the complete course that explain you, but here I'm just demystifying this term. And the traffic is coming in this direction. When this broadcast come on R1 will basically send it towards R3, R1 will send it towards R4, and R1 will also send it to R2 via EVPN fabric. And when R2 receives it, will R2 will send it back to C1? The answer to that is no, because it is received via R1. R1 and R2 are part of same ESI. ESI is a concept we have talked at length in multihoming, but basically ESI will tell R2 that R1 is connected to the same end host. So it will discard this packet here itself and will not send it towards C1. This is a split horizon rule in EVPN. So basically we are not sending back what we have received from the same host. But in this case, a general question, why R1 is sending it to R2 when R2 will discard it anyways? The reason why R1 sent it to R2, even though R1 also knows that they are part of same ESI, because there can be some port connected here in the same VLAN which is associated here. So even this endpoint also need this broadcast. So that's the reason it is sending the traffic here. But then what is this designated forwarder? What is the role of designated forwarder? This is one of the common confusion that I always see. Now listen to me very carefully. When the traffic is coming from C1, when the traffic is coming from the end host, basically there is no role of DF. Traffic, one broadcast is coming on this link. Other broadcast may come on a other link, let's say here. In this case, R2 will send that here, and because this is belong to the same ESI, R1 will not forward it on this link, but R1 can very well send if there is another endpoint in the same VLAN connected here. So the key point that I wanted to demystify in this video, one common confusion that I wanted to demystify in this video, that when the traffic come from end host, there is no role of this DF. DF only comes into the picture when the traffic is coming from EVPN core and going towards the end host. Like in this case, when this broadcast packet come here, so it will hit both R3 and R4. But because our R3 is the DF, this guy will only forward the traffic here, this broadcast packet. R4 will simply drop it because this is not the designated forwarder. So to sum it up, the DF, the designated forward, is primarily concerned with the traffic flowing from EVPN core to the multi-homed host, not the traffic from host to core. That means, let's just sum it up here. If I erase all this ink, when the broadcast traffic come in this direction, it can very well come on link 1 or 2 depending on the hashing from C1, but no role of DF on this side. The role of DF will come into picture here when the traffic come from the core side, travel to the end host side. In this case, only R3 will forward this broadcast packet, not R4, so that we avoid this duplication of frames when it is received at C2. I hope this makes sense. So let's just go back here. So this was the key point that I wanted to emphasize in this video. The DF, designated forward, is the only PE responsible for flooding bomb traffic received from the core network. This point is important. Onto the Ethernet segment for the multi-homed host, in our case C2, and the non-DFPE will block the bump traffic from core so that the end host does not get the duplicate packets. So the DF side only come into picture in this side if our traffic is flowing in this direction. If the traffic is flowing in this direction, then yes, you will have your DF here. I hope this video was informative and was able to explain this bump traffic handling and the relationship of DF to you guys clearly. Thank you so much for your time, and I will see you in the next video.